Hello everyone. Now we shall look at intermediate code generation. So intermediate code generation is the fourth phase of compiler design. So after lexical, syntax and semantic analysis, intermediate code generation has come up. So as the name suggests, intermediate code generation is used to represent the high level language in an intermediate form, and after this phase we will convert this intermediate code into final, which is targeted code. So intermediate code generation is represented in two forms. First is the linear form and second one is the tree form. In linear form we categorize it into two parts further. First is the postfix and second is the tree address code. And in tree form is also divided into two categories. First is the syntax tree and second is the directed acyclic graph. Directed acyclic graph in short form called as DAG. Among all of this form, tree address code is the popular one. Means in GATE exams or in various textbooks, tree address code is explained in detailed manner. So we have to focus only on tree address code, but just for an example, I have illustrated the postfix, tree address code, syntax and directed acyclic graph as well. So let's take an example. Let's say I have an program. In this program only one line of code is present, and the code is x plus y into x plus y plus z. Okay, so this line of code contains three variables x, y and z, and there are two operands present, two operators present. One is plus and second is multiplication. So addition and multiplication are the two operands and three variables x, y and z present. So if we have to convert this particular line of code into postfix notation, so postfix, you know that in data structure you also you have already learned this postfix, prefix, postfix and infix expression. So in data structures and in this intermediate code generation, postfix is same. So where we learn prefix, postfix and infix, here we already learn only postfix notation. So if you convert the particular line of code into postfix notation, then you will get the result as xy plus xy plus z plus star. So this is the final postfix expression for this line of code, and it is in linear form. Why it is in linear form? Because the expression is written in the form where you can get all the variables and their operators easily. Okay, now after seeing the postfix of this particular line of code, let's see the tree address code. So in tree address code, always remember there are maximum three variables present in a tree address code. So if I convert this particular line of code into tree address code, so I have to assume temporary variable. Let's say temporary variable t1 contains x plus y. Okay, temporary variable t2 contains x plus y. Temporary variable t3 contains t2 plus c. t2 means x plus y and plus c. So x plus y plus z. t3 contains t2 plus z. So x plus y plus z is t3 and x plus y is t2 and t1 is nothing but x plus y, and finally we have to multiply the x plus y and x plus y plus z. So t4 is equal to t1 into t3. Okay, so in this tree address code there are maximum three variables present in any expression. Here 1, 2, 3. So three variables are maximum in tree address code. Now in syntax tree, how can we construct the syntax tree for this line of code? So first you have to analyze that which operator is having highest priority. So in this particular line of code, star is the having higher priority operator. So star will be present at the top of the node. After that, then plus, and plus will contain plus will contain x and y. Similarly, in the right side part, plus operator is present, and this plus operator on the other side contain z, and on the left side it will contain plus, and this plus is x plus y, x or y. Okay, so first we have to add the x and y variable, and on the other side we have to x and y together, and the resultant will add to the z, and finally we have to multiply them. In directed acyclic graph, the syntax tree is represented in short form, means the common part or the common prefix is captured together in both the expression. So for this line of code, the directed acyclic graph will be star, then plus, and then x, y. So x and y here common, so I can just represent with z, and this will depict the line here. Okay, so this will mean that I have to add x plus y plus z here. Okay, and x plus y is presented already here, and finally we have to multiply them. Okay, so these two forms are used for intermediate code generation. What is linear form and tree form? And among all the intermediate form, 3 address code is the most popular. Okay, there are certain types of operations which are supported by intermediate code. In the next video we will see those operations.